So, my dear friends, today I will start one of the important topic, and yeah, this is what casting. Casting we read in the two parts. One will be sand casting, and after that we'll discuss the special casting like investment casting, cell casting, slush casting, die casting. All that comes under the category of special types of casting. So I will cover this session in the two session, or you can say the two things, separate things. One will be the sand casting, other will be the what, my dear friends, special casting, right? So before starting the casting, I want to play one two video so that thing will be more cleared. Okay, then we'll start the sand casting. See, I am going to just play one or two video, just to give 1 minute. See here, I am going to talk about the sand casting, how the sand casting is happened. First of all, my dear friends, you have to understand a little bit about the everything is written. Don't worry, you everything is written. What is Python? What is Python allowance? Everything is written. I will share. Before that, try to understand. First of all, you have to be, suppose, manufactured any product. So first step, you have to be create the pattern. Pattern is what? It is replica of the product. Whatever product you have to be manufacture, so it will be the replica. Here we can see a pattern are made of the top and bottom, that different things. Here we can see this is the pattern which is replica of the product which is to be casted you have. Now actually na, if the generally pattern you are going to made in the two parts, if especially if it is a bigger casting, then you have to do separate in the two part. One half is that one, another half is that one. One is called cope. Now you are going to pour sand. It is called sand casting because now that was the pattern which was inside that, and above that you are going to be fill the sand. This sand have some different property, we'll see. Now this is called ramming, right? This is called ramming. Like that I am going to do ram, so that there should be proper interatomic forces or proper contact between the sand particles. It should not lose, otherwise that may get break. So you target, just do like that, so that there should be proper bond and they will not going to be break. Like now, see my dear friends, just you have did that like that. You have removed the pattern. Have you seen? You have removed the pattern. One more video I will play. You have removed. Now see the impression of the pattern. Okay. Okay, you have removed the pattern, and you can say the impression of the pattern is come over the this, you can say, the sand. Now see what we have to do, just play the video, that will come over that, and total, since half was that portion, half was that portion. Okay, and when they are going to overlap each other, whole pattern will come. We'll see. Now you are going to do like that. Here we can say one hole is there, right? From that hole I am going to pour the molten metal. Molten metal, obviously, you have a furnace. In the furnace, lot of furnace you have, like Poplar furnace, okay, induction furnace, different types of furnaces are there. Little bit we will discuss about the furnace also. So from the furnace you have taken that molten metal. Now you are going to pour the molten metal. Once you poured, this is called basically riser. You have poured the molten metal, it is filled, and from there we can see, okay, it gets filled totally. Now allow it to solidify. You have allowed it to solidify. You have given some time so that it will solidify, and once solidify, okay, see there, okay, that was the last step, right? Now once the that molten metal solidify, we will get the product whatever your pattern was. Okay, and your pattern is your manufactured product is ready, and you can use whatever application you required. So that is the basics principle. This is the very basics principle of the sand casting. First of all, you have to be create the pattern. Pattern is nothing but it is a replica of the product. Now after that, around that pattern you have to fill the sand in case of sand casting. After that, remove the pattern by the using a cope and drag. This is called cope and drag box. Okay, by using cope and drag box, this pattern will be removed, and now the cavity will be there. In the cavity, you have to pour the molten metal, allow to solidify them, and you will get the product. That is a very simple concept behind the sand casting. Okay, one more video I will play and then we'll start our discussion. This is same video, yeah, or different? This is little bit different. See, you have seen half of the pattern you have. Okay, इसमें back नहीं कर सकते. Can I do bike? Okay, no problem. Half of the pattern you have given there. You have seen here. No. From that say another half you have given. See. Now give the sand. Now give the sand. Yeah, you are going to give the sand. Do the ramming if required. No. Remove the pattern. No. Remove the pattern from the sand. From there. Okay. And after that you have to pour the molten metal, and here you can say the gas is going to be removed and your product gets ready. And after that remove break the sand and get the product. First of all, my dear friends, first thing I want to ask, have you little bit idea you will get now how the sand casting is getting? Everything is clear? Now I will discuss in the details every terms. Clear everything? Tell me. Clear? Till now clear now how this thing is happening? Not visible, sir. Not visible. What not visible? Okay. Visible na? Okay, okay. Okay, it was your old message. Okay, fine. Good. So, my dear friends, a few things is there. One is called pattern. No, see, various things. When you have to remove the pattern, so you need to give the some pattern allowance. I am coming on the PDF. Then we'll see. Right. Where is my PDF? Okay, okay, download sand casting 1 PDF. Okay, before coming to the question, let's move to the last. Okay, that all are numericals, no problem. In the sand casting, what you have to do, my dear friends? That is the question. We'll see later on their solution. First of all, you have to make a something like that. This is called, okay, from there will be connected of the runner, okay, and from the runner there will, this is the cavity, this is the cavity that you have to be get the product, and there will be the riser, and from here you are going to be pour the molten metal. Here molten metal is poured, okay, this molten metal will come through that and it will fill that cavity. And obviously, my dear friends, around that cavity, what is there? What is this? This all are sand, na yaar? This all are is sand, na? This all are is sand? Yes, sir. Okay, let me change the color so that it will be more. That all are is sand. That all thing is sand. Sand, sand, that all are sand. Right, sand. What is this? This all thing is what, my dear friends? Sand. Sand. Okay, this all thing is sand, and allow to solidify. Once it get solidified, now break the sand and take your product whatever you have required. Here we can see your casting. You can say your pattern is here. Your pattern was like that. Okay, your pattern was like that. No, my dear friends. Okay, that is a basic concept. This is called pouring basin. This is called runner. I will discuss all that in the getting system design. Till now, this is called pouring basin. This is called pouring basin. Pouring, pouring basin, right? This is called sprue, my dear friends. This is called sprue. This is called runner, runner. And you know, this is called gate, my dear friends, from which molten metal goes, na? So this is called gate. And obviously, this is called cavity. This is called is what? Cavity, in which you have to pour the molten metal. In the cavity, earlier pattern was there. So that is the basic concept. Now see, my dear friends, we can say, sir, here I have to be discuss the pattern allowance. Now the question is that why you need to study the pattern allowance. Okay, my dear friends, see, see there, actually I have a lack of space, no problem. Suppose that was your pattern. Let's assume, my dear friends, that was your pattern, that is your pattern, and obviously pattern will be inside the mold, inside the, you can say, the sand. So these all are sand, my dear friends. These all are sand, right? These all are sand. Try to understand in the sand casting that all are sand. it is all around the sand like that. Suppose this is the sand, okay, that all thing is sand. Now my dear friends, you know, you have to be remove the pattern, you have to be remove the pattern, then you have to pour the molten metal. So now you have to be take out that pattern. Now see my dear friends, once you are going to be taken out that pattern, can you say there will effect on the sand? Obviously, sir. Sand may be distorted, sand may be erode. In all that case, your product will be very, very bad. And that's why you need the Python alliances. Python alliance basically going to be provided so that any problem is there that should be overcome. Let's start with the story. First Python alliance, I am going to discuss about shrinkage alliance. What is shrinkage alliance, my dear friends? Shrinkage alliance, you know, if anything going to be solidify from their liquid state, their volume decreases or increases. Tell me everyone, anything which is going to be solidify from liquid state to solid state, their volume always decreases. Anything, there are few exceptions, like in case of water freezes now, their volume decrease increases. Only few exceptions you have to remember, in which case during shrinkage volume increases. Otherwise, in all the case when it is going to be solidified, the volume decreases. So tell me the exception. First you have to understand the the exception from where we can say, like if you talk about water, in case of water, when it solidify, comes in the solid state, its volume increases. First thing. In case of bismuth and cast iron, in case of bismuth, another example, in case of bismuth, if that gets solidified, again their volume increases. Certain case in the gray cast iron also we can see the same thing. Other than that, all other aluminum, that all are, gray cast iron is not coming there, leave it. Aluminum, all other product, when they solidify, they will contract. Now my dear friends, see, you have a, see, listen, you have required that much amount of shape. Let's assume you have required that much, and you have made the pattern in the same way. You have made the pattern in the same way, whatever you have required. You have required that, you have made the pattern like that. Now my dear friends, once I fill the molten metal, that cavity will be filled, that cavity will be filled, that cavity will be filled, that cavity will be filled. Okay, sir. If that cavity is filled, and once this molten metal start solidify, they will contract. Means, sir, their size will be less than that of the required, sir. And it is good? No, sir, it is not good, because actually I require that one, but due to the contraction, the actual product that I will get, it will become something like that, sir, and this is not feasible. And that's why, my dear friends, I have to do something. So suppose if I am getting, okay, that much amount, it is contraction, and if I need that much amount of python, so already I will make a bigger python, I will make a python like that, I will make a python like that, so that if they will solidify, then I will get that much amount. Yes, sir. So that is called shrinkage allowance. Means shrinkage allowance always provided on the python, and it will be enlarged in the size. Whatever you have required, the size will be the python size will be the larger than actual requirement. So okay, that is the first thing you have to be keep in mind. Here we can say shrinkage alliance added to the python dimension to compensate for the reduction in the size when the when the metal cools and the solidify. Is it visible or should I zoom? Visible or should I zoom, my dear friends? Visible now? Right. When the molten metal cools and solidify, the amount varies with different metals since it have unique shrinkage rate. Means what the from which rate it will shrink, that depends upon the different materials. The shrinkage rate will be different. So that was the first thing. Now second, what is machining allowance? You know, my dear friends, later on I will teach one thing. One of the biggest drawback of the casting product, that their surface finish is not good, because here sand na yaar, here sand na, so surface finish is not good. Generally, especially in the sand casting, surface finish is a very bad. So you have to do the machining also, to so that surface finish looks like better. You have to do the machining. Yes, sir. If I do the machining, some dimension will change now. So already I have to be give the last step. Suppose I have to be cut from that one. So already I will give the larger size of the python, so that at the end I can do the machining and I will get the required shape, whatever I have required. So this is called machining allowance. And especially in the sand casting, it is a very major concern, my dear friends, because surface finish of the sand casting is not good. Very bad it is. So here we can see here another thing that you have to be understand the machining, or you can say the finishing allowance, extra material provided on the casting surface to allow for removal by subsequent machining process. This ensure that after machining the product meet the final specification and surface finish requirement. This, what is the third? This is called draft allowance. What is draft? A slight taper given to the vertical face of the python. This makes, okay, see my dear friends, I am coming to the draft python. I think I have one diagram. I have diagram. I am coming on that. Have it given or not here? Yeah. See, this is this is your actual casting you needed. This is actual casting you needed, and you will make a python like that. Now you can ask, why, sir? Why I have to be like that? You know, my dear friends, see here, see, just think. Suppose that is your python you have made, and which is inside the sand, which is inside the sand. Obviously, that all are the sand. Huh? Yeah, that all are the sand, black sand, right? Once I remove the python, there might be possible, my dear friends, there will be lot of erosion of the, when they will go up, there will be erosion at the edges, and which gives the very bad surface finish, or in certain case the dimension of the product becomes different than that of actual. Okay, so what I can do, sir? Actually, what I will do, actually I need that type of python, but I will make the python in that way. I will make the python like that. I will make a python like that. That is not that much amount of larger. Actually, it is 1 or 2 degree, 1 to 3 degree maximum. Just for seeing purpose, I am saying. Now, see my dear friends, that all are inside the sand, that all are here. This sand is now, this is now sand, this sand, okay, sand is there. Now tell me, once you are going to remove the python, now your python is that, now this is your python. So since here already maximum contraction, and once I take it out, now the problem of erosion is recovered. Now there is no problem of erosion, because that is the maximum. Now here we can see, so it can be easily removed, and that allowance is called, is what? Taper allowance. And later on, after the welding casting is completed, I will cut the material from there, and get like that. So this is actually, you can say, this is called python allowance that you have added, and after the machining I will remove, and that type of allowance is known as what, my dear friends? Python allowance. Now tell me, whatever allowance you have known till now, just tell me one thing, my dear friends. Whatever allowance you have read till now, is it positive allowance or negative allowance? We can say, sir, these all are positive allowance. Why? Because that all are going to be enlarge the size of the python. So the allowance, because of which the size of the python gets enlarged, is called positive. What is called positive allowance? So whatever you have read till now, if you talk about shrinkage allowance, you talk about machining allowance, you talk about this draft allowance, that all are known as positive allowance, because it increases the size of the object. Okay, sir, fine. Now come to the next one. What next? Distortion. My dear friends, distortion allowance generally comes because of distortion. Especially this type of allowance we can see whenever you have to be weld, you have to be cast U shape or V shape or L shape. This type of allowance is you can find in the product when you have to be cast a product having shape. Please remember that one, U, V or L shape. In that case, what is happening? Since their cross section changes, and at where cross section gets changed, the solidification rate gets changed, and that's why I have to be use the distortion allowance. So mainly you have to be keep it is distorted, especially when the profile is getting changed. So you have to be just keep in mind distortion allowance generally used in case of the product required in the shape of either U, V or L. Other than that, no need of distortion allowance. Other than that, no need of distortion allowances. Clear? So keep in mind that thing. U, V, L shape, then only distortion is required. Otherwise, no need of distortion requirement. Distortion allowance. Fine, sir. Now come to the sake allowance. From name itself indicates sake. Right? Sake. What the meaning of sake, sir? What the meaning of sake, sir? See, my dear friends, suppose just listen here. That is your product that you have to be casted, and you pattern basically, and obviously this is, let's assume, sand. That all are is what, my dear friends? That all are in sand here, right? Red sand is there. Now see, what you will do before, okay, you are going to give that draft allowance. Even draft allowance is also there. So before taking off, what you will do, little bit you will do left right, little bit, huh? Little bit amount, very little bit amount will go to, before taking out that pattern from the this cavity, you are going to do left right, little bit amount, and that's why the size of the cavity increase little bit, and that type of allowance is known as what, my dear friends? Shaking allowance. So now the question is going to be asked, so shaking allowance is which type of allowance? You have to make comment, positive allowance or negative. Tell me, make a comment, is it positive allowance or negative allowance? Tell me, yaar, is it positive or negative? What you think? Right, my dear friends? That question was asked in your exam. Which of the following is negative allowance? The answer will be the wrapping allowance, because in that case, the size of the cavity, you have size of the pattern is not so. My listen, just listen one thing, my dear friends. So what is happening? Actually, we can say the product that I will get, because I have to little bit like that. So the size will be something like that. Size will be something like that. Now tell me, here, if you require, listen, you require that type of cavity, you require that much amount of cavity, or you require that much type of product, but you have make the pattern will be lesser in the size. Why? Because during the removal of the pattern, I have to be shake little bit. I have to be shake little bit. So actually, the size of your pattern is less than the required cavity, or less than the actual product you required, and that's why in all the case size was larger, but here size is lesser. That's why, my dear friends, it is called negative allowance, because it has reduces the size of the pattern. Right? Okay, I will come on the question, then we will discuss. Here we can see a brief. Here we can say the shrinkage allowance. Okay, if the pattern will be, it will be shrinkage. So you have to be, actually you require that much, that. So, but you will make a larger pattern. Actually require this, but you have to make a larger pattern. First thing, this is machining allowance. Again, you have to do the larger. Draft, you have to little bit taper. Distortion, especially UV shape or L, right? And this is wrapping. Wrapping means you have to little bit left and right, and that one. So that was the thing that you have to be just keep in mind, my dear friends. One more thing I want to be discuss here, then I will come to the question parts, and then we'll discuss different types of pattern also. My dear friends, shrinkage allowance now, it can take place in the 3 stage, my dear friends. What 3 stages, sir? Please tell me. So little bit I am going to discuss more about the shrinkage allowance, even it is not written there, but I am going to discuss little bit more. Question is going to be asked on that concept also. So no available. Okay, let's come to the anyway. Okay, I am going to discuss here. See, my dear friends, you have a molten metal. Can you please repeat? Yes, why not? I will, obviously I will repeat if you ask. Obviously, why not, yeah? Someone is going to be asked, sir, why it is called, negative like that? There is going to be asked, right? Hmm. Say Kelvin's wrapping. Python size may be slightly increased to compensate for the enlargement of the mold cavity caused by wrapping and shaking the python during its removal of the mold. Python size may be slightly increased to compensate for the enlargement of the mold cavity caused by wrapping. See here, my dear friends, just listen. See, just people who have asked, suppose this is your python, this is your python, okay, and this is inside the mold. This last time I am going to discuss, this is inside the mold, my dear friends, okay, this is inside the mold, this is inside the mold. Now tell me, unmute yourself, can you take out that directly from this one? Is it good or bad? It will be very bad. It is good or bad to taking directly? Can you take directly it out from the sand? No, sir. Lot of problem you can create if directly you are going to be taking out. So what I can do? What I can do, my dear friends? I can do little bit wrap, very small amount. Like before, because sand is tightly packed. If you remember, sand is tightly packed. This is sand and tightly packed. Just now you have seen video, na? It is tightly packed. So once I remove, na, there will be problem. So before removing, what I will do, Mister, I will do little bit amount left and right, so that gap little bit increases. So that gap will little bit increase, and it will be easy. It will be easy to remove the python from that cavity. That's why even you can say the size of the. So what is happening? Actually, your product, since you have wrapped, so actually cavity will becomes like that. Little bit. It will be becomes like that. Cavity becomes like that, huh? Right. So you will get the product like that. Your product will be like that. This will be the product. So you just tell me, your pattern is smaller than the your pattern is smaller than the actual product or larger. Tell me, larger or smaller, Mister Babu, and which one is there? Chindananda, whatever. Tell me. Everyone can say me. Here you can say, why you are getting confused. We can say the size of the cavity is more than that of the python. That means python size is less than the actual product. So that's why it is called negative. Clear now? Clear now, Mr. Babu and everyone? Fine. Okay. Okay. So we'll discuss one more thing. I will discuss in the question. I was discussing the question, whatever I was going to discussing right now. First question on the screen. Draft on the pattern of the casting provided for shrinkage allowance, identification, taper to facilitate removal from the mold, machining allowance. Tell me fast, everyone. Tell me fast, everyone. C for Chennai. Yeah, everyone now. So today I am going to discuss only sand casting. Tomorrow I will discuss the special casting. So today all will be the sand casting question. And one session I will take the casting defect. So 3 session here. Yeah, just now you have seen here. This is 1 to 2 degrees, sometimes 3 degrees written in the book. So no problem. Everyone has given the right answer. Okay, now that is the another question. And now a student can say, sir, you haven't taught that one. First teach, then I will answer. Yes, wait. First chaplet are placed between mold and the core in order to. No need to answer. First try to answer. Try to understand the things. My dear friends, everyone have to be answer. Everyone means everyone you have to be answer. If you are not answer, then no problem. If you answer, still no problem. My dear friends, this is, and you know, this is the cavity. This is the cavity, right? This is the cavity, and we'll get the, there will be riser. This is called riser. Okay, this is called riser. Now I am going to pour the molten metal. Everyone have to be answer. And obviously this is inside the sand na yaar. Arey yaar, this is inside the sand na. This all story inside the sand na. Yes sir, this all story is inside the sand. This all thing is inside the sand. Kala kala black black sand. Black soil it is. Okay, it should be any soil. Don't worry. This is just for fun I am telling. Okay, you have poured the molten metal. This is your molten metal. This is your molten metal you are going to pour. Tell me, once they fill that cavity, the product will be solid or hollow. Tell me, sub everyone, this product will be solid or hollow. What do you think? Product that will get, it will be solid or hollow? Tell me fast. Everyone? Right. Yes, sir. The product that I am getting here, it will be the solid. It will be the solid. Yeah. But sir, suppose I have to make a product which is hollow in the nature. Right, sir. Which is hollow in the nature, and I have to go through the sand casting. Yeah, I have another approach also by which I can make the hollow product. Like sand, you have a centrifugal casting, but I will discuss about that. Currently, I am focused on the sand casting only. So, if I need to require the hollow product, then what I have to do? Now, suppose my dear friends, I will put something. I will put something like that. Everyone tell me. Now I am going to put, it is visible, visible, this color, visible, a little bit visible. Now I am going to put something like that. Now tell me, now the product will be hollow or solid? Everyone, now the product that we will get, it will be hollow or solid? Obviously we can say, sir, it is hollow. And my dear friends, that thing that you have placed inside that, this is called core. This is called is what, my dear friends? Core. So what is core? Always keep in mind, core is basically going to use in case of sand casting to obtain the hollow casting, to obtain the hollow section. So this is called core. Actually, I have figure also. Let me see. They have given no. Yeah, everything is there, my dear friends. See, everything is there. This is pouring basin. From there molten metal is coming, that all are the sand, and you have to require the hollow casting. So you have placed that one. This is called core. This is called core, right? This is upper half of the python, and this is lower half of the python. Upper half is called cope. Always keep in mind, upper half of the python is always called cope, and lower half of the python is called drag. You have seen in the video that I have played in the starting of the session. So it is called drag, it is called cope, and in between line this is called is what? Parting line, and this is called core, this is called cavity runner, and this is called chaplet. What is going to be asked? Now my dear friends, see there, everyone just think, now it will be in the air. No sir, I need to give some support na sir, then only they can stand na. Right, you are getting right. So sir, I need to give some support sir, I need to give some support here sir, this like that, like that I need to give the support sir, and that support is called is what, my dear friends? Chaplet. So chaplet is what? They are just going to be support the core in case of getting the hollow casting. So now come to the question. So what will be answer of that one? Reduce the directional solidification. I will discuss what is directional solidification. Discuss, don't worry. Help local alloying the molten metal. Prevent the core movement due to buoyancy. Help easy removal of the coal from the casting mistake. Help improve the purity of metal. What could be answer? Everyone. C for Chennai, everyone. That's good, my dear friends. C for Chennai. Here, you know, here buoyancy effect can also be there because molten metal inside that. So buoyancy can also be there. Na? Here you can see this is actual diagram that I have came with you guys. See there. This is chaplet. Okay. Since the molten metal filled in that, might be possible they will exert the buoyancy force. If they will exert the buoyancy force, might be possible the core will be little bit distorted, and if the core will get little bit distorted, the product that will get will be totally different from the actual requirement. Yeah, right sir, and that's why this here even in the above side I am going to be used. So this is called chaplet. So always keep in mind, chaplet is going to be support the core and also going to be control the movement of the core because of any buoyancy force, right? So that is the thing you have to be keep in mind about the chaplet, and the thing is cleared. And good thing is that most of you guys have given the right answer. Fine. Come to the next question. Dot 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 normally provide a steeper temperature gradient so that direction solidification as required in the casting can obtain chill, runner, riser or getting system. What could be answer? What could be the answer? A for apple. Hmm. Right. Someone student can say, sir, in the starting you have talked about runner. I know the riser. Getting also know, but sir, chill don't know. You don't know what is chill. My dear friends, in the sense, just listen one thing. Suppose this is the pattern, right? This is the pattern, and obviously it is inside the sand. Obviously, the sand is there. Huh? There is a lot of sand. Huh? Okay, same color. You will know sand. Let me see. These all are sand. This all are is what, my dear friends? Sand, 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 sand. Now see, everyone, they will solidify equally in all the direction right now, because nothing is there. They will solidify same date in all the direction till now. Yeah, it will solidify in all the direction, no problem. Now my target is to solidify faster rate and some point. So what I am going to do, I will put the some metal particles there. I will put some metal particles there, and my dear friends, metal have higher thermal conductivity than that of sand, so it will allow solid, it will faster solidification in that direction. So by providing the chills, the directional solidification I am getting, it will solidify from that one. That's why it is called directional solidification. So chill is going to provided for the directional solidification. Even I have came with the diagram here also. You guys, here we can see external. Okay, this is external, so it is called external chills. It will solidify. Here I have sent the some metal particles. This is inside the sand, so it will start solidifying that one faster. So it is called chills. Here it is inside the internal, so it is called internal chills. So always keep in mind, chills is going to provide to get a directional solidification in case of sand casting. In case of what, my dear friends? Sand casting, to get the directional solidification. Now this is the next question, and various times the question is going to be asked on that one. Even in the BEL 2023, that type of question was asked. So answer that one. The solidification time of casting is proportional to, this is called Chernow rule. Okay, I am coming on the answer, and try to remember it one for a longer. See, solidification time is given by K equal to V upon A whole square, or you can say solidifying time equal to K into V upon A whole square. K is called constant, basically solidification factor, that value will be given, and it is a constant. Once I remove the constant, can I say it is proportional to V upon A whole square? Yes, always keep in mind that formula. Various times the question on the different exams has been asked on that formula. So inject that formula in your blood. Solidification time is equal to K B upon A whole square, where V is called volume of matter, A is called its surface area, and you have to be remember that one. No, this is another question. Green sand is a mixture of 70% sand, 30% sand and 70% clay, 50% sand, 50% clay, 70% sand, 30% clay, 90% sand and 10% clay. What do you think? Green sand is a mixture of what? Everyone have to be answer. So my dear friends, you have to remember that thing going to be asked. If we talk about green sand now, So in the green sand, most of the part will be what? Green sand is a mixture of silica sand with 18 to 30% clay, and uh, basically you have to be just keep in mind composition green sand, basically silica 70 to 8%, 18 clay is 18 to 30%, water 2 to 6%, additive could be some, I will teach you a coal powder again you are going to be used. Coal dust is mixed in a green sand to prevent the defective casting or casting defect. Coal dust that is also going to be asked is mixed in a green sand to prevent defects casting. So whenever you have to talk about the sand, what is the green sand? So 70% sand and 30% is what? Clay is called is what? 30%. Yeah, C right now, yeah, not A. Chennai is the right answer. So try to keep in mind that thing, my dear friend. 70% is sand and 30% will be the clay, and little bit sawdust also you are going to be, coal dust you are going to be used. Now see, core print are used for, again that is that only three types of question is going to be asked. Core print are used for strengthen the core, form set to support and hold the core in a place, fabricate the core, none of the above. What do you think about that? This time, this time, this time everyone is going to give the right answer, and good thing you have to remember, that is excellent thing. Form set the form set to support and hold the core in the place. See my dear friends, I have one diagram. Huh? Where is the diagram? They haven't given. Core print used for making the, okay, but I diagram one have. Oh, see my dear friends, there is a core, this is the core. So core print is basically, this is like that. So they will basically one type of projection, and in this you are going to fit the core. You cannot fit the core anywhere. So the place where you need to fit the core, there will be one type of impression over the pattern, and this is called is what? Your core print. Even it is also going to be whole like that. See, I am coming in the diagram here. We have seen that diagram earlier. Come on, that diagram, let me little bit zoom out. Where was that question? See my dear friends, here this is your core now. This is your core. So you can put core anywhere in the sand, in the cavity. No sir, I cannot do like that, sir. You cannot do like that. So over the pattern, I have to give some impression. Okay, I need to put the core here. So that type of some impression will be inside that, and this is called, simply we can say, the core print. What? HP. HP. Just wait for that now. What our target? Our target is to first make the concept clear to everyone. Na? Then I will move to the obviously different types of question, as you have seen in the cast welding. So I will take all different types and difficult numerical require according to requirement of your exam. So keep patience first everything, because some same matlab different types of student are there na. Sometimes are freshers, someone is some experience. So being a teacher, it's my responsibility here. So things should be clear to all the student, right? Might be possible you are giving second time or third time exam, so you have knowledge about little bit about that, but there are few students. It's my duty to make it clear. Then I will come to the question, different question. You have different resources. Even I will share the some question to practice to you. You have a BEL question already. We will share. So try all that question. And yes, suppose you are getting difficulties, don't worry, share with me now. But in the class, it's my first priority that things should be clear to all the students. Right now, Mr. PK, not PK, HP. So don't worry about that. Yes, I will take all types of questions. Don't worry about that. If you have seen the previous lectures, you have did the same thing. But yeah, step by step. Right? You are telling sir that all are easy question. Think must be clear. I know that all are easy question, and you in your exam they are not going to ask the very difficult things. Just analyze your exam also. Okay, don't need to waste time on that one. So this is called your core print. Fine. Okay, that was the question. You can very answer easily answer. What will be answer? Very easy question. Again, we can see Mr. Everyone can say. Okay. Shrinkage allowance will be there. Right. Easy question. Not easy because you have already discussed everything. So you find it is easy, right? But that is not that much amount of easy. Give answer that question. SP and everyone answer that question, yeah. Answer fast. Everyone answer. Only few answer I am getting. What about others? Very few answer I am getting. Mr. HP. See there. I know I haven't discussed their concept. Even I started discussion in the initial, but I left it. So you can see only few students are able to answer that one. No? But all have paid. No? So my target, every student have cleared the concept, right? So that if even they will provide, obviously I will take all different types of question. Be assured about that. But you have to start from the very basics. If you have watched my first lectures, I have told you will start from the basics by assuming you don't know anything. That means 0 to the higher level you have to be reached. So please keep patience here. Huh? Obviously I will. See, my dear friends, okay, no problem. A student, you can give your feedback. Okay, can tell me someone is telling sir is discussing easy question? No, easy. Concept need to be clear. Then we can do all the things. Right, see here. While pulling a cubical casting of side 40 undergoes 3%, 4% and 5% volume shrinkage during liquid state, phase transition and solid state respectively. The volume of the metal compared to compensate from the riser is. See there my dear friends, I am going to be explain that question. This is your cavity, as you know. This is your cavity, and yes, cavity will be in the sand, and this is your runner. This is what is this? Hmm? Oh, makhi. Like that. You are going to pour the molten metal. Just listen, see my dear friends. You are going to pour the molten metal inside that. Yeah, I have poured the molten metal. I have poured the molten metal. Okay, and and this is your riser. This is your riser, and the molten metal goes in the riser also. The molten metal has been gone in the riser also, and obviously this all thing inside the sand. This all thing is inside the sand. Inside what sand? Right. Now see my dear friends, see, you have to be design a riser in such a way, see my dear friends, once they start solidify, so their volume start decreasing, right? And when whatever volume is going to be decreases, that much amount of metal, you can say the molten metal supplied from the riser. Always keep in mind, solidification time in the riser is always more than solidification time in casting. Always keep in mind, you have to be design riser in such a way that solidification time in the riser must be higher than that of the cavity, or you can say the casting to be produced. Now see, suppose my dear friends, let's assume I am telling one thing is there, having temperature 500 degrees Celsius, 500 degrees Celsius, and I have to be come to the room temperature 25 degrees Celsius, right? That is the molten metal at 500 degrees Celsius, and ultimate they will cool to the 25 degrees Celsius, that means to the room temperature, right? Now listen, let's assume the phase change takes place at 150. Let us assume phase change, liquid to solid will takes place now. So at some temperature the phase transmotion takes place. In the thermodynamics will be taught. So let us take their phase change temperature is 150 degrees Celsius. Let's assume phase change takes place 150 degrees Celsius. So what is happening, my dear friends? We can say, sir, 500 to 150 it is cooling. So we can say 500 to 150 it is called sensible cooling. It is called sensible cooling. Will be taught in the thermodynamics. 150 this is pure liquid state, and again it is coming to 150 again, but this time it is a solid state. So during that phase change takes place. During that what phase change takes place, and after 150 you are reaching to the room temperature 25 degrees Celsius. This is what we can say the sensible cooling. Again it is called sensible cooling. So how many stages comes? First sensible cooling, after that phase transformation, and here liquid, here liquid, no solid, here liquid, and after that what? Solid. So three stages: liquid, phase transformation, solid. Liquid, more precise we can say phase transformation. Liquid, phase transformation, and solid. Now tell me, whatever sensible cooling will takes place, as cooling started, volume start decreasing. And as volume start decreasing, since you have designed the riser in such a way that they will provide the metal to that cooling, during that cooling. So this thing is, that means sensible cooling is going to be covered by the metal of riser. And also when phase transformation takes place, this is also going to be overcome by the riser. And this, no, once they get the solid, again the temperature is 150 degrees Celsius, they have to become 25 degrees Celsius, again this will compensate, this compensate will be provided by the pattern itself. This is provided by the pattern itself. I will make the pattern in the larger. So basically riser is going to be compensate the liquid state or sensible cooling, or the meter requirement during the phase transfer or phase change. So now my dear friends, answer that question. You can answer. Yeah, 3% volume shrinkage during the liquid state, phase transition is 4%, and solid state is 5%. So riser na, the what the question, compensate from the riser. So riser will be the liquid state is 3% plus 4% of the phase transition, when phase is going to be transition. So 3 plus 4 is 7%. Clear to everyone? Yeah, for solid shrinkage, you have to be design the pattern itself in the larger. Right now, your name, my dear friends, I forget pronounce that different thing. Yeah, okay, that depends upon the things. Chindanana. Okay, fine. You are going to give the right answer. Okay, clear, Mr. Babu? I think you have asked. Clear now? So always keep in mind three things is happening. First, sensible cooling. After that, phase transformation. After that, solid cooling, or you can say solidification. So two, phase transformation, and this you can say the liquid state, cooling in the liquid state coming from the riser. Rest I am going to overcome. Solid shrinkage. This solid shrinkage always going to by the design of, you can say the design of pattern itself. Design of pattern. If sometime that question is going to be asked, so try to keep in mind this is going to be overcome by the design of Python. Okay, fine. So here it is given 7%. Which of the following material require the largest shrinkage alliance while making the Python in the casting? Yeah, tell me what you think about that. User Tejaswi, Pardeep, or Adit, Babu, Banerjee, Chandni Priya, Amal, Manoj, विनय पवन विश्वराप गोपाल मंडल जी, एक तो नंबर लिखा है, हनिंगाना, कोहली जी, प्रसाद कोहली, रमेश कुमार, रमेश, ओके, तेजस, मनोज, राठौर, मुकेश, सुरेश. What you are going to be asked? How many member? Okay, answer that question. Ask management about that, huh, Manoj? Please ask that thing the management. See here. See, my dear friends, that data you have to remember. You don't have any option because that thing is going to be asked. If you talk about shrinkage allowance, this is mm per meter. In case of shrinkage allowance, in case of cast iron, 7 to 10.5 mm per meter. White cast iron 21, level cast iron 15, steel 20, brass 14, aluminium 18, right? Aluminium alloy 13 to 16 mm per meter, and bronze is 10.5 to 20. Now, see according to the given option, what will be the option here? See now according to the option, what could be the answer? Plain carbon steel, yeah. Which of the following material required the largest shrinkage allowance while making the pattern for the casting? It will be the plain carbon steel. So D for Delhi is the right answer, not C for Chennai. Try to remember that data, na? Try to remember that things. Try to remember that value. Shrinkage allowance will be the, but in that way. So you have to be remember that way. Still have 20 mm per meter. Fine. What is the function of scheme bob provided in the getting system of the mold? What is the function of scheme bob provided in the getting system of the mold? Can answer that question before you? Then I will come to the question. See, what is scheme bob? First try to understand. Then I will come. Okay, some student is going to be answer, no problem. See the scheme bob. My dear friends, this is something like that. This is the pouring basin. Pouring basin. You can see here. Okay, this is, you know, strainer, all that, splash core, no problem. Here we can say this is skim bob, right? Suppose if any impurities is coming now and this is lighter, so it will be collected at the upper part. Okay, and the impurities which is coming is the heavier, then it will be correct. Before this is your cavity, once they will go to the, if some impurities will go to the cavity, it will produce the, you know, casting defect, na, right? So your target is that that should no go in the cavity. Okay, so that you are going to be use the skim bob, and in skim bob is designed in such a way, if any lighter particle, it is something like a churning, if lighter particle is going through that, then it will be collected in the upper part, and if any heavier thing is going on, it will be connected here in the bottom part, and that is the function of the skim bob. It is going to be remove the impurities from the molten metal before entering to the cavity, so that if any defect can produce because of that impurity will not happen, and that is the good thing. So here I have one more diagram to you guys. So here this will be the more clarity. We can see you are going to pouring basin sprue. Here it is a skim bob. If anything lighter will goes up, heavier goes down, chalk, and ultimately this is your mold cavity and your riser and all that. Upper half of the is called cope, lower half is called drag. Always keep in mind. Okay. Skim bob is nothing but, my dear friends, na Banerjee. Skim bob is here. It is designed in such a way, na, that it can take the impurities. So if any heavier impurity, if any lighter impurities, so it will come from the above of the molten metal, because it is lighter, so it will float. It will float. Here will be one something that will take out that impurities. If any impurities which is heavier, so it will sink and it will come in that way. So there will be something like that where this impurities usually settle down. So in that way we are going to remove the impurities. Directional solidification in the casting can be improved by, yeah, answer that question. Directional solidification. What about others? No. See, chills, yeah, chills is the fine, but chaplet is not. Chaplet basically we can say to support paddings. I am taking chills and padding, chill, chaplet and paddings. What is padding, sir? Chills I am getting, chaplet I am getting, but what is this padding, sir? Yeah. See, my dear friends, I am coming with the paddings. Here we can see this is called paddings. This is called is what? Paddings. What is this padding, sir? So directional solidifying casting can be improved by chills and padding. Chaplet is used to prevent the support of the core. My dear friends, just listen one thing. I want to ask to everyone. Okay, what I have to be asked, sir? My dear friends, just listen here. This is your cavity, right? I am going to discuss about the paddings. Okay, I know you have remember paddings is going to be, but now the question is that why? Why it is allowed the that directional solidification? My dear friends, see, this is the molten, this is the some cavity. You have to pour the molten metal. You have poured the molten metal, and they have reached. Suppose this is something like that, huh? This is something like that. Okay, and they have filled that one. Now, if you want, I need directional solidification. You know, my dear friends, if anywhere more amount of substance will be there, so they will have more heat, or they require the more heat to change the phase. Like just take just take 1 kg of water, okay, and 1 quintal of water, and both the case you have to be change the phase. Obviously if I have 1 quintal of water, even it will also boil at 100 degrees Celsius corresponding to 1 atm. They will also boil at 100 degrees Celsius correspond to 1 atm. But yeah, sir, if 1 kg water I have, the heat requirement is less compared to if you have 1 quintal of water, compared to that the less heat will require. Now see, my dear friends, what I am going to do here, we can see I want that cooling will take place from that segment, but initially it is a straight line. Initially it is a straight line. So I will everywhere same cross section, I will not get any directional solidification. I want to get direction solidification. So what I will do, what I will do, my dear friends, everyone, I will mix This was initially requirement. This was initial requirement. But actually what I will make? I will make the thing like that. I will make the thing like that. Change that color. Okay. I will make the thing like that. Right. Now I will ask, tell me from which the solidification will started, from point 1, from point 2 or from point 3. From which point solidification will start first? Everyone to give the answer. From which point the solidification will start first? 1, 2 or 3? Cross section 2 2. Everyone is giving 2 2 2 2. Yeah, everyone is coming with the 2 2. Why? Because sir, to have minimum area na sir, to have minimum area na sir, so minimum area, right? So here heat will be the faster. Here it will be, here less amount is there, less amount of substance is there of the molten metal, so they will require less heat to get solidified. Yeah, so it will start solidification, and that you have provided now, my dear friends, that you have provided now, that you have provided, this is called paddings. So paddings is also going to provided to get the direction solidification. To get what? Directional solidification paddings you are going to be used. So my dear friends, what ultimate conclusion? Ultimate conclusion is that, see, listen, chills and paddings going to use the directional solidification, chaplet going to be support, and core print basically one type of impression on the Python where you have to use the core. That four things you have to be keep in mind for always, so that you will not find any difficulties if question is going to ask from the sand casting. I think you can answer that question very easily. Riser design, obviously freeze after casting freeze. What you can say answer of that one? Tell me fast. I think everyone can answer that question. It is again easy question. Yeah, right. Freezes after casting freezes. Yeah, it was easy. Everyone can answer that question. No problem. I am coming on that question. Are used to support the core inside the mold to carry its own weight and overcome the metal. Yeah, what will be answer of that one? What we can answer that one? Everyone? Everyone now? Right. Great. Chaplet. Yeah, fine. I will come on the once I discuss the riser, na, then I will take that question. Don't worry. Answer that question. Try to answer that question fast. We have 1 minute of time. Answer fast. What about others? I am getting a few answer only. Done. Everyone is getting, someone is 20, someone is 40. What the fault is there, yaar? Hmm? Hmm. Yeah, fine. See, my dear friends, a spherical drop of molten metal radius is given 2 mm, solidify in 10 seconds. A similar drop of radius 39.4 mm. What that? I think 4 mm. Radius is 4 mm, not 39. That is just a mistake, na? 39.4 is what? Radius is 4 mm. Okay, radius is not 39, huh? Each 4 mm will solidify. See my difference, we can say, sir, just now we have discussed Ts equal to K into V upon A whole square, right? So Ts will be proportional to V upon A. V will be volume 4 pi r cube. What will be volume, my dear friends? Area 4 pi r square, right? What will be 4 by 3 pi r cube? If we talk about volume, this, so it will be 4 by 3 pi r cube. Or it will be 4 pi r squared whole squared. From there we'll get one relation, right? What will be Ts? Proportional to 4 by 3 pi r cube upon 4 pi r square whole square, right? So 4 pi will going to be cancel out, 3 will comes out some constant. So Ts is proportional to r square. R R square, right? Ts is proportional to R square. So we can say, sir, Ts1 upon R1 square is equal to Ts2 upon R2 square, right now, my dear friends? Right, everything. So Ts1 is what, my dear friends? It is 10. R1 is, you can say this will be 4. This you have to be calculate. Ts2 you have to be calculate. Right, this is R2 is what? 16. From there we'll getting answer here. Huh? R by 3. But I have taken that constant na yaar. Simply I have taken it as a constant. Direct proportionality is there na. So I have taken it as a constant na. Here we can say 1 upon area. By doing that, by solving, what answer? 40 is coming out to be. A for apple. Everyone have get A for apple, tell me. A for apple, everyone. Okay na, Kiran? C, apple, apple, apple. Yeah, most of have given the right answer. Okay, fine. Come to the next question. Solve that question within a 1 minute, not more than that. Same question it is also. Answer fast. Banerjee is coming with B for Bombay. What about others? Tejas, not getting your answer here. Why? What about others? Waiting for more answer. RK dost, answer na. Banerjee ji, answer. Priya, where is your answer? Manoj dost, answer fast. Nagraj, not getting your answer. B for Bombay. Okay, let me check. So a two cubical casting of same metal and size of 2 cm side and 4 cm side are molded in a green sand. Find if the smaller casting solidify in 2 minutes. Well, the expected time of solidification of larger casting will be. You have to going to ask what will be the solidification time of larger casting. First, let us check your answer, because all of you are going to give the answer D for Delhi. Sorry, 8 minutes before Bombay, you guys are going to give the answer. Yeah. And good thing is that all of you have given the right answer. Fine. Everyone have given the right answer. Solidification time. So by that way, we will get the answer. No problem. Everyone have given the right answer. Even you can do very easily to typical casting same metal size and 2 sheet and 4 cm side molded green sand easily. If a smaller casting solidify in 2 minutes, expected time solidification in the larger casting, very simple we can do. We can simply say, sir, Ts is equal to proportional to, directly I can say V upon A whole square, right? From there you are getting Ts is proportional to what? R square. In that way, we will get the answer. Ts is proportional to what? R square, right now? Now do and make a calculation very easily. We can say, no, sir, T, lower upon R, lower square, smaller, whatever you can say, equal to 2s, bigger, B upon R, B means bigger square. But what the question, very easy it was, huh? Answer 2 casting on same size of 2 cm and 4 cm side on a given side. If the smaller casting solidify in 2 minutes, a smaller casting solidify in 2 minutes, and 2 means it is 4, right? So what will be that? You have to be calculate, and this will be 16. Again, same question, na? So 16 into 2 upon 4. 4 4 is 16 is equal to TSB. 4 4 is 16 to 8 is coming very easily. Okay, one thing, my dear friends, whenever that type of question is going to be asked, in which various parameters, not even in that subject, whenever that type of question is going to be asked, in which various parameters are there and only one parameter is going to be changed, so always try to take in the proportionality form. It will be very easy to solve that type of questions. It will be very easy, right? So you have seen that is only second times. हाँ ऐसे चलेगा काम, right ना? So keep in mind that things. Okay, few questions left, let me complete that. Okay, answer that question. Answer that question, my dear friends. What will be answer of that question? You know, what answer? Sprue Chennai. Molten metal is transported down into the mold. Transported down, yeah. Gate, sprue, runner, or riser. See, just now I have told you, if you have remember, right now, this is called basin. From there, this is called runner. And this is your cavity, right? This is called gate. This is called gate. Or sometimes it is also called in gate. This is your runner. This is your sprue. Right. This is gate runner. This is here. It is your riser, na? This is your riser. This is called sprue basin, pouring basin. Molten transported down. Here, if you are going to pour, yeah, everyone has given the right answer. Just if you pour, so down is coming from the sprue, na? It is coming down from the sprue, na? So B, yes, runner is a horizontal passage, right? Horizontal passage. Riser is that one. Gate, from here it is going to be entered. So it is called gate. Okay.